So let's see how uncertainty or statements which are not 100% true can really wreak havoc with our whole notion of logic. Let's suppose we have predicates or relationships A, B, and C, and rules such as, for all values of x, if A of x is true, then B of x is true. Similarly, if we have for all values of x, B of x is true, then C of x is true, then normal logic allows us to entail that for all x, A of x is true, so B of x is true, B of x is true, then C of x is true. Since this holds for every value of x, it holds for all values of x. So we have the inferred rule that A of x implies C of x. And this logical entailment of one rule from a pair of rules is fundamental. We can simply not reason if we don't have such freedom to entail new rules from old ones. But this fundamental principle that we rely on has a problem if these statements are no longer certain. For example, suppose we say that for most x, A of x implies B of x. An example might be that most firemen are men. Another statement might be that for most x, B of x implies C of x. An example might be most men have safe jobs. The inferred rule for most x, A of x implies C of x does not follow. It is not true that most firemen have safe jobs. Whereas if we said that all firemen are men and all men have safe jobs, we could say that all firemen have safe jobs. But obviously that's not true. The job of a fireman is not safe. And the reason we have this confusion is that while for most x, almost all of A, which is the set of firemen, they are men, right? So very few of them are women, just this piece over here. And for most of these B's, which are the men, most of them have safe jobs, which essentially include all of these people, including possibly some firemen who basically don't go on fire calls but do only administration. But the trouble is that because of this uncertain relationship, you don't have a situation that most A have safe jobs. Only a small number of A have safe jobs. So this statement for most A of x implies C of x, is simply not true. So this basic entailment of A implies C from A implies B and B implies C, a very fundamental piece of logical inference, simply doesn't hold when we have uncertain statements. And this creates much more problems than the fundamental limits of logic. Another problem one can get into with normal logic if one is not careful is the notion of one event causing another event. That is causality. That is, statements are not necessarily true all the time, but their truth values change over time because one event causes another event to become true. For example, if we have a statement like, if the sprinkler was on, then the grass is wet, which we might write this as S implies W. Sprinkler implies wet. We might have another statement that if the grass is wet, then it had rained last night, which we might write as, if the grass is wet, then R, that is, it rained last night. Logical inference would probably blindly combine these two statements to make S implies R through logical entailment, which states that if the sprinkler is on, then it rained last night, which is blatantly false. So something has gone wrong because our statements are no longer about things which are always true, but they're about things which cause other things. The problem is that causality was treated differently in each statement, which resulted in an absurdity. Well, it turns out that we've seen causality earlier without actually having realized it when we studied classification. Let's look at classification again. What were we doing then? A statement like, if the sprinkler is on, then the grass is wet, is also a statement saying that the fact the grass is wet is an observable feature of the event that the sprinkler was on. Similarly, if it had rained, the grass being wet is again that W is an observable feature of the event of raining. The trouble is, the statement that if W is observed, then R happened in the past is not a statement about the forward cause and effect of R having caused wetness or S having caused wetness, but is a statement about what might have happened if one observed W. Remember, in classification, we were doing something similar. We were observing the features that one found in the world and trying to infer their causes. So in some sense, this reasoning about R having happened, having observed W, is like concluding which class of event actually is being observed. Is it sprinkler or rain? We are observing the features and concluding what kind of event we are actually observing. A kind of classification or prediction using a classifier. Not exactly, but something very similar. This is an example of abductive reasoning, where one tries to infer the most likely cause given a set of observations or features. Abductive reasoning is exactly what we do when we compute the class of an observation using a classifier. It's also a form of reasoning. It's not deductive, that is, going from sprinkler or rain to wetness, which is actually the likelihood computation, but is the a posteriori calculation of having observed W, what is the most likely cause? Is it sprinkler or rain? If you view this in the language of classification, the confusion about having incorrectly concluded that sprinkler implies rain goes away. So one needs to distinguish between deduction and abduction. Fairly deep, but in the language of classification, it becomes fairly simple. Let's see how.